I would like to give you another example regarding finding area under a constant function. This time the constant function is written as a piecewise function. In the yellow box, I have g of x equals to 6 if x is between 2 and 14. So y is equals to 6 if x is between 2 and 14 and y is equals to 0 otherwise. Check out the graph down below. Y equals to 6 is a flat horizontal line at just y equals to 6. But the line doesn't go all the way to the right and to the left because I restrict the line between 2 and 14. So we have a line y equals to 6 between x equals to 2 and x equals to 14. So if you just make a cut at 2, make a cut at 14, you see that there is a rectangle, right? And I have to strongly emphasize that the area exists inside this region only. So what happens if you go outside of this region? So that's why you have to consider the piecewise function g of x equals to 0. G of x equals to 0. Otherwise, what does that mean? If you have an x value outside 2 and 14, then the function is y equals to 0. So y equals to 0 is a horizontal line that lines up with the x-axis perfectly. So do you see the color coding? Do you see the red line? Y equals to 0, we have a piece on the right hand side of 14. We have another piece on the left hand side of 2. The reason I use an open circle for the red line is because if you want to check the function using vertical line test, so you have to draw a vertical line at 2 and a vertical line at 14. I want to see exactly one intersection, so that's why at 2 and 14 for the red line they must be an open circle. If you use a solid circle, then there are 2 points at x equals to 2, so the function is not 1 to 1 anymore. Okay, so now move your eyes to the right, find the area under the constant function where x is between 3.8 and 10.9. So first of all, you copy the graph over and then you locate 3.8. So let's say 3.8 is right over there and then 10.9 is right over there. So my job is I am looking for this area. So what is the area equal to? The area is equals to, so to find the base, you use a bigger x minus smaller x. Do not use 3.8 minus 10.9 because if you do so, you get a negative. An area cannot be negative. And then you multiply by the height. So what is the height equals to? The height is 6, right? So this is the height. Is 6 units up of the x-axis. So multiply by 6. And then what do you get? So you have a 10.9 minus 3.8. Then you get a 7.1 times 6. So you multiply by 6, then you get 42.6. So 42.6 is the area of the shaded region. So let's move on to the next one. The next one is between 8 and 14. So 8 is right over here. And then 14 you get the cut, and then this is the area that I am looking for. So the area is equals to base, which is big X minus small x times the height. And then this one we have a 6, right? 14 minus 8 is equals to 6. And then we have 6 times 6, that is equals to 36. How about the next one? The next one is from 10 to 17. So 17 is already outside of the domain. So let's point out where 10 is. So let's say this is a 10 and then 14, suppose 17. So suppose 17 is right over here. Then where is my area? In this case, you only have area from 10 to 14. Why? Because 14 and beyond is already outside of the domain. The domain of what? Check out the piecewise function at the very beginning in the yellow box. So g of x is equals to 6 if x is between 2 and 14. Do you see the very first picture? I said area exists inside this region only. So from 2 to 14, I can give you some area. So just give me x is between where and where, I can give you an area. If you go outside of this domain, what domain? 2 and 14, then there is nothing I can give you. So it is just that easy. So the next step is you calculate the area. Of course, you don't take 17 minus 10. You can only take 14 minus 10 because once you go outside or beyond 14, I cannot give you any area. And then you multiply by 6. So this one you have 4 times 6. That is equals to 24. All right. And then we have 2 problems left. The first one is from 0 to negative 3. So let's match the color code. So x equals to 0 is right over here, right? So this is x equals to 0. And then x equals to negative 3. Do we have any area? The answer is no. Why? Because from 0 to negative 3, that is outside of the domain. The domain of what? We have y equals to 6 if x is between 2 and 14. This is what I gave you at the very beginning. If you go beyond, less than 2 or greater than 14, then there is nothing I can give you. All right. So the area is just equals to 0. If you go outside of that, I cannot give you anything. But for the previous example, well, you have some area from 2 to 14, so 10 to 14, all I can do is give you 10 to 14. From 14 to 17, forget it. There is nothing I can give you. Okay, let's handle the last one. The last one is 14 to 20. So 14 is right over here. So suppose 20 is over there. Do we have any area? The answer is no, because again, once you go beyond 14 or go less than 2, then there is no area. So the area is just equals to 0. Alright, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, subscribe to my channel if you are on your way out. I truly appreciate your help and support. I will catch you all in the next lesson.